So what is this shape? This is a V shape. What does that mean? Okay, it looks like this. And we have to remember it. It bisects, divides in two pieces, the first and the second quadrant. This is the graph of the absolute value of x. And we have to remember this forever. The quadratic function looks like this. The absolute value looks like a V. So now when they ask us to graph the absolute value of x minus 3, somebody needs to explain to me what needs to be done. And what needs to be done, remember, here we shifted the graph up 13 units. What do you think we're going to do now with the absolute value of x minus 3? Exactly, exactly. 3 down, 1, 2, 3. And now I get, notice that the lines have to be parallel. So just plotting some points or just using the calculator, it gives some insight, but not something that will stick with you forever. So when we graph an absolute value function, the simplest one, and we can branch off from there, the simplest one is a V shape. It bisects the first and the second quadrants. And I can shift it up and down. Of course, there are other, we call these transformations. Shift up and down is this. Left and right is a different story. And we have other things that you will learn in the next class that we do with these graphs. But for now, we have to establish and remember the quadratic function, tiny little thing here, symmetric with respect to, like also symmetric here, opening up with a vertex at the origin. This one, a V function. And then from here, we can do other things. That is what is important, not plugging in some numbers and plug and chuck. So now understanding the function and how it looks like, which of these, I know it's a silly question, which of these will you pick? Of course, you cannot pick the ones that are in the other direction. Of course, you're not going to pick B because we're not shifting it up. So of course, the only option is shifting it down 3 units. Good. Okay, this is a different situation. You'll see what happens with this. Should we work on it?
Yes.
Perfect. I just want to look at B and C and B and D for a moment. Looking at B, what would you say about this? Is this a function or a relation?
Relation.
Yes, by the vertical line test, it's not a function. You should disregard it completely in a blink, because this is a function. For each x, I will get only one y value, for sure. So this makes makes no sense. What about D?
Also relation.
Of course. So these two are disqualified in a second. So let's look at this and see what happens. So let's look at y plus 6. Notice that this is a different situation. So y is the absolute value of x plus 6. Let's analyze. This is very important to understand. So this is the basic function, and then minus 3. So the change is outside of the absolute value. Here, as you notice, the change is inside the absolute value. This was a downshift. This was an upshift. But when we change x into x plus 6 or x into x minus 2, the transformation is left and right, is no longer up and down. When I change x, the transformation cannot be up or down. When I change y, this was y value. From the y value, I subtract 3. Go down or up. But when I change the inside, in other words, I'm changing x into x plus 6, this is a totally different direction. It's either left or right. And we'll find out which one it is in a minute. I'll explain. So for the y equals the absolute value of x plus 6, I know that the base function, the simplest possible function, is this, of the absolute value. This is y equals simply the absolute value of x. Notice that when x is 0, y is 0. Now the question is, where does this point go? Does it go to the left, this point, in this function? Does it go to the left or it goes to the right? If it has to stay on the, and it stays on the y-axis, y is 0. Y is 0. What makes y 0? Which x makes y 0? Which x makes y 0? And there is only one.
-6?
Indeed. This is the graph of the absolute value of x plus 6. It shifts the graph 6 units to the left. What if I ask you now, where will you graph y equals the absolute value of x minus 2? Where will you shift this graph?
To the right.
To the right too, because y is 0 when x is 2. Here it is. So this is y equals the absolute value of x minus 2. So, yep. So, let's look at the original function, the basic function. See when x is 0, y is 0?
Yeah.
Perfect. Now I'm asking myself, where will this function go? But this line has y equals 0. So for y to be 0, what should x be?
See, so you add 2 to each side, and then x.
I'm not solving the equation like that, but it has to go to 2. Because if I consider on the other side, look what happens. This point cannot be part of this graph. How come? Let's plug in -2. -2 minus 2 is -4. The absolute value is 4. And the y is not 0. So I cannot shift this graph to the left too. Because if I put it here, this point is not part of the graph.
So we're kind of combining the zero property principle.
No, we're just solving, you're just finding the x and y intercepts, basically.
Why do we have to make y equal 0?
Because I need to find the point on the x-axis where the graph is shifting. And the equation of the x-axis is y equals 0.
Okay.
So here, when y is 0, x must be -6. If you want to move it to 6, 6 plus 6 is not 0. So this point, 6 comma 0, is not on this graph. But this point is. When you plug in -6, you get 0. But when you plug in 6, you get y equals 12. So you get something that is not on the x-axis.
What you're saying is, like, if you put y equals, or like replace y with 6, it would be plus 12.
So when y is 6, very good point. We haven't studied solving equations that are absolute value. So when y is 6, you have two options. X plus 6 to be negative 6, and x plus 6 to be 6. How come? Negative 6 in absolute value is 6. 6 in absolute value is still 6. So we have to solve two equations. One of them is x equals 0. But the other one is x equals negative 12.
Oh,
When x is 0, y is 6. When x is negative 12, the absolute value of negative 6 is 6.
okay. That makes more sense.
So now let's look at the graphing calculator to solidify this, I hope. So in y equals, clear everything. The first one, for the absolute value, you go to math and numbers. Math and numbers. Click enter. And this is x. And then we want to use the same thing, math and numbers, absolute value. And we have x plus 6. And then the last one, math and numbers and absolute value, and x minus 2. Now the standard viewing window is good. I'm going to go to standard, zoom standard. Please watch very carefully. It will happen very fast. Blue, red, and black. I use the standard because standard is good right now. Blue, red, and black. Absolute value of x plus 6, absolute value of x minus 2. This is the absolute value of x minus 6. I meant to say x plus 6, of course. The absolute value of x plus 6 and the absolute value of x minus 2. X minus 2 shifts the graph to the right. X plus 6 shifts the the graph to the left where the 0 is for y.
Is that because the y-intercept would be negative 2? I mean, plus 2.
The y-intercept is 6 when x is 0. When x is 0, y is 6.
Right, and negative 2 is still 2.
Yes, the y-intercept is 2.
Okay.
Yes, that's another way. Very good point. Very good point. You can determine the y-intercept, but careful because this will be also the same y-intercept.
Right.
So it's better to guide yourself based on the x-intercept. So for this function, where could the x-intercept be? Obviously, when y is 0, x must be negative 6. Because if this is 0, this must be negative 6 to obtain 0. What would happen here? Well, if this is 0, this must be 2. This is basically just for you to understand, but these transformations are not really part of the class. But I want you to understand them because they will follow you in the next class and the next class.
And they're the absolute value functions?
Yes. So this is the absolute value. You just have to read it. And it tells you what function it is. So when I read the absolute value of x plus 6, it's an absolute value function. If I read the square root of x plus 6, then it's a square root function. So this will be a square root. Once you read it, you know what it is.
There are only 3 functions, the quadratic, absolute value, and square root?
Yep. Oh, we have tons of functions. There is no end. There is absolutely no end. There is no end. We have trigonometric functions. We have inverse trigonometric functions. We have hyperbolic functions. We have cubic, fourth degree, natural log, exponential functions. There is no end. These are the basic ones. X squared, the absolute value of x, the square root, and so on and so forth. I'm going to try to introduce you to them so you have an idea. I have to be honest, like always with you. I'm not going to ask you to graph something like this on the test. It's not, you're not ready for this. Just to plot points and then look at the graph, use a graphing calculator. This is not. I'm explaining to you the graphs so when you get to them in the next course, you say, oh, okay, she mentioned that. What's the point in putting a problem like this? You don't know how it looks like unless I explain to you how it looks like and why it moves to the left and doesn't move to the right and so on and so forth. Just plug and chuck in the graphing calculator. What's the point? Okay, the same thing. This is, we talked about this, so let's discuss it. When they pop up, why not? So we have y squared minus y equals 5. Of course, I'm going to rearrange this and solve for y. Negative y equals negative x squared plus 5. And of course, I'm going to multiply by to solve for y. I will multiply by
-1?
Sure. So y equals x squared minus 5. Now we know how to graph this because we know how to graph x squared. And this is outside of x. It's not inside of x, meaning it's not like this. It does not change x. It changes y. Good. So how will you graph this? We know this.
Yeah, smiley face 5 minus 5.
Exactly. And where will the graph shift?
Yeah.
Exactly. Now this is a point, right? This is something we understand. So y equals x squared minus 5. Because, go ahead.
I only said smiley face because positive things are smiling.
Good. Good. So x squared shifted down 5. Please remember, when we change x, we shift the graph to the right because that's where the point belongs. When we change x with plus, we shift the graph to the left because that's where the x-intercept will go. Good. Good. Now this is very important. We need to understand, and here's a graph. First, I'm going to ask you, is this the graph of a function, yes or no? And why?
Yes.
Yes, by the, and we have to say, yes, by the vertical line test. This is the graph of a function. Awesome. They're asking us to find, we're not going to read from my graph, but good. So let's take a look. So this is pretty similar to the graph we are looking at. It's not perfect. Notice that the function comes from below, crosses the x-axis, crosses the y-axis, goes to a maximum, comes down, touches the x-axis, and goes up. These 2 points are called x-intercepts, are also called the zeros of f of x, assuming that this is called f of x. Why the zeros? Because they intersect this line, y equals 0. They're also called roots of the equation f of x equals 0. All these mean the same thing. and this is the terminology that is very important. X-intercepts or zeros of the function or roots of the equation f of x equals 0. Or the roots of the function. Okay. Now, this one obviously is called a y-intercept. A function can have more x-intercepts, but it cannot have more than one y-intercept. So now I'm going to share my screen and let's identify them. Can anyone give us the x-intercepts in an ordered pair format?
Minus 1, 0,
Minus 1, 0.
and 3, 0.
Perfect. Now you said 0 for y equals x, for the x-intercept for y. When y is 0, x is negative 6. When y is 0, x must be 2. Good. Can anyone now, not from my graph, can anyone give us the y-intercept in an ordered pair format?
0, 9.
0, 9, indeed, because it's on the line that has x equals 0. So these are the x-intercepts, and this is the y-intercept. Good, perfect. Okay, the same thing with the intercepts. I think okay. Good. Express the relation using a different form. Okay, so we have 0, 1, we have 1, 4, and 4, 5. 0, 1, 1, 4. Okay, can we choose 0, 1, 1, 4, 4, 5? C, perfect. Same thing. Identify the domain and range. Excellent. Finally, we need to understand. I'm going to enlarge it as much as possible. So I'm going to mimic this graph on my paper, and then we'll come back to it. So here's the graph. Pretty much. Okay. They're asking us to find two things. Domain, which is values of x. They're asking us to find range, which is values of y. So let's start with values of x, with the domain. Notice that the graph goes on forever, according to this arrow and this arrow. It goes on forever. Which means, and also the domain is read on the x-axis. This is where we read the domain. Because it can go on forever, the domain is between negative infinity and infinity. From the leftmost point till the rightmost point. So domain in this case, D, colon, negative infinity to infinity. This is it. For this function.
Is the domain always the x-axis?
Always, because it's the values of x.
Okay.
Perfect. Now, values of y. Values of y are determined on the y-axis from the lowest y value till the largest y value. Low to large, to high. Now, we have to read from the graph, not from my graph. What is the lowest possible y value that the function expands over? From
1
to,
infinity.
yes. So we will write R, standing for range, from 1 with a bracket, because the point exists, comma infinity, of course, with parenthesis, because infinity is a symbol, not a number.